So activity 1. Mr. Leonard applies for a personal loan of 150 from a bank, and the loan officer has informed him that over the years, he has received 2920 applications and that the probability of approval was 0.85. Question: what is the average and standard deviation of the number of approved loans per year? So this is a binomial approximation. So binomial approximation only has about 3 formulas that you need to know. Number 1, the mean is simply given by NP, which is called the average. The variance is given by NPQ, and the standard deviation is given by square root of the what? Of the variance. So in this case, what have we been given? Been given our N. N in this case is 2920. The probability is 0.85. So in this case, you need to understand that if you're given a P as at 5%, the remainder is your Q, which is 15% or 0.15. So how do we find the mean? The mean is NP. So we just multiply 20 to 920 and 0.85, and our average is called 2482. That is our mean. Standard deviation is the square root of the variance. So NPQ, the 15 is the difference from 1. So we multiply 2920 times 0.85 times 0.15. So here we get 19.295. That is called our standard deviation. Are we clear? Same question has been slightly iterated. We are told that our N now has changed to 0.654, whereas our probability or P is 0.82. So like I said, if this is 0.82, our Q should be what? 0.18. So to find our mean, it's NP, so 2654 over 82, which we get 2176.28. Our standard deviation, we simply multiply 54 times 82 and 18, 0.18. Our answer we're going to get is 19.792. That is how we find our standard deviation and the mean. That is how we do it. Quickly, we've been given a question on normal distribution. So we're told that 100 light bulbs have a mean of 120 mean life, and the standard deviation is 20. How many bulbs will require less than 90 days? So there's an N given here. So whenever the N says, if the question is how many bulbs will expire in less than 90 days, if 50 are sampled, we'll need to calculate our standard deviation because of standard error. But here we're dealing with the whole 1000 bulbs, so there's no need of fusing in the N. So remember, using our ISA, step 1, illustrate. Our mean is always found in the middle. So our mean here is what? 120. Then our standard deviation is what? 20 days. And you're finding less than 90. So 90 is just less than what? The 120, we put the 90 here. So less than 90, we're shading to the left. So using ISA, step 1, illustrate. Step 2, shade. Step 3, standardize and apply. So we need to standardize this 90, and the formula for standardization is given by X bar minus mu over standard deviation. So 90 minus 120 divided by 20. What do we get? 90 minus 120 divided by 20. So this will give us a negative. So this is always at 0, and when we divide this, we get negative 1.5. All the readings from the Z tables are starting from this area. So you're going to check your table under negative 1.5. Table under negative 1.5. What are we going to find? So after finding our Z, which is negative 1.5, we go into the Z table and check under negative 1.5 to see the reading. So negative 1.5, somewhere here. 1.5 under 0, so this is a reading 0.06681. So meaning the reading from here reading from here to here is 0.06681. So that's a reading that we're having. So you don't need to subtract from 1. So that's the probability that we are going to have here. So it means the question has asked for the number, how many, not the probability. So don't end here, multiply it by the 1,000. So 0.0681 times 1,000, we get 66.8 bulbs. So in less than 90 days, we're going to have bulbs numbering 66.8 that will expire in less than 90 days. We're also told that it is decided that if all the bulbs need to be replaced together, what interval should be allowed between replacements, if not more than? Not more than means less than. I repeat, if it is decided that all the bulbs need to be replaced together, what interval should be allowed between replacement if less than 10% should be replaced before they expire? All right. So in this case, we do the same illustrate. When our 0 is here, we have 120 there. And if less than 10%, so this is 10%, subtract 10% here. 10% in decimal is the same as what? 0.100. So we'll go into the table and check for 0.100 inside the table. So 0.100 is going to be found as follows. Let's check for 0.100 for me in there.
It's 0.5000 on top there. Up.
So 0.0, you are reading from inside the table. 0.100, you are going to find the closest. Find the closest. This is 0.9. It's not this one, but this one. What's the reading for this one? This is 0.09. This is 0.10.
1.28.
1.28.
Negative 1.28.
Yes, negative 1.28.
Yeah.
So negative 1.28 is what we're going to write. So here we had, this is a question that boggled a lot of your colleagues. 120 here, the 10%, 0.10. So meaning this one will be 0, this one will be negative 1.28. So we want to find the value x here. So we know that z is equal to what? X minus mu over standard deviation. So a negative 1.28 is equal to what? X minus mu, which is 120, divided by what? Our standard deviation. What is our standard deviation? 20. Yes, can you calculate? Find the value. Okay, so you get where the 1.28 is coming from, isn't it? Are we all together where the 1.28 is coming from?
No,
Yes.
Colin, I'm a bit behind.
On where the 1.28, I said this is 10%. 10% is the same as 0.1000. Then you go inside the table and look for 0.100. So when you go into the table, I said here they're in order, chronological order. So all these are 1, 1, 1, 1, 11. This is 10, but the nearest 10 is about 0. It is 9%. So 10% is just this one here, the closest. 10.00. This is 9.8%. So this is 10.02%. So this is the what? The closest figure. So how do we read this figure? You add negative 1.2 and what is on top here? 0.08. So collectively, this is 1.28. That is why we're putting 1.28 here. Is that clear?
Okay, I get it. Thanks.
Then you cross multiply this times that one. And when the x is this side, this one will come this side to add. So x will be 94 point what? 4. So this is now where we can conclude that our x will take 94 days. The bulbs will be released after 94 days, an interval of 94 days. So that's where the 94 is coming from. Is that clear? So now we go to part C. Part C is a binomial distribution. How do we know it's a binomial? The incidence of occupational disease in an industry is such that the workers have a 20% chance of suffering from it. What is the probability that out of 6, more than 4 will contact? So to start with, so a binomial, we need to understand that we are only given 2 things, N and P. All right, what is our N? We have 6 there. What is our P? We have 20%, which is 0.2. So if P is 0.2, meaning our Q should be 0.8. The 2 must add up to 1. So in data summary, are we together there?
Yes.
So now, using the binomial distribution simply says we're going to have n, x, then p to the power x, and q to the power n minus x. So our n is 6, so we're going to do the 6 combination what? So we're being asked, first of all, to explain, firstly, you need to explain what are the characteristics of a binomial distribution. Who remembers the characteristics of binomial distribution?
It is bell-shaped, is symmetrical, and the area under the curve adds up to 1.
That's for a normal. I'm talking about binomial. What are the characteristics of a binomial distribution? Okay. So number one, binomial distribution has two possible outcomes, a success or a failure. It has a fixed number of trials, which are denoted by N. Probability of a success is denoted by P, and the failure is denoted by Q, or 1 minus P. The chances are equal and events occur independently. Those are the characteristics of a binomial. So now we are going to qualify this to be a binomial because the chances, the trials are 6. So we are given the number of trials. The P, which is the success, are given 20%, meaning the Q should be the failure, which is 80%. So find the probability that 4 or more. 4 or more means what? We're going to calculate probability greater or equal to 4. So meaning we're going to look at the probability of what? 4 itself, plus the probability of what? 5, plus the probability of what? 6, which is the last number of the trials. All right. So what is the probability of 4? 6 combination 4. What is our P? 0.2. And what is our Q? 0.8. So the 4 comes there, and the difference 4 minus 6 minus 4, it's a 2. And you get the probability there. Okay, the other one, 6 combination what? 5. Right, so here we have 0 point what? 0.2 times 0 point what? 0.8. So here we have 5, and here we have a 1. Then finally we have 6, combination 6. Going to multiply. Here we have 0.2, and here we have 0.8. We put the 6 there, and we put the difference there, which is, I hope you know how to compute. I hope you know how to compute the combinations. So what is 6?
Mr. Collins, where are we putting 2? Is it like 8 to the power 2 at the end?
The
The
4
first
comes
one.
there. 4 comes there, the difference, 6 minus 4. All right, it's 2. And 5 comes there. 5 minus 6 minus 5, 1. The top must always add up to this. So 5 plus 1, 6. Then the 6 comes here, and 6 minus 6 is 0. So this is just the format that we're following here. So you need to punch on a calculator. Okay. Do you know how to do the combination?
Yes.
We were trying in the afternoon, but I think we can do it together. I kind of failed to find the answers.
Okay. So depending on the calculator that you have, am I audible? Am I breaking?
Audible.
All right. So depending on the calculator that you have with you there, a simple or basic calculator that I can use is the Casio. So when you're calculating the combination, I'll show you the calculator now. So if you're using a Casio calculator, your calculator will look something like this. So the combination is found directly just below I hope you have a calculator nearby. I think it should be somewhere here.
Yes.
So you press 6 combination 1. So 6 combination 1 equals, what are you getting? 6 combination 4.
I found 6.
15.
Okay, 15.
Oh, 15. Yes, the first one was another. Yes, 15.
Is everyone getting 15? So
Yes.
6,
Yeah. Yes.
6 combination 4. You press 6 combination 4, then equals, you get 15. About 6 combination 5 is what? 6. And 6
Six.
combination 6 is what? 1. Are we together? So in this
Mhm.
case, this will be 15 times 0.2 to the power 4 times 0.8 to the power 2. What's that?
I think I understand where I was making a mistake.
Okay, that's great. So similarly, this 15 combination 6 combination 5, when you get a 6 times 0.2 to the power 5, you put your answer there. And 0.8 to the power 1 is 0.8. Then you compute all of them. Then 6 combination 6, we're going to get 1. 0.2 to the power 6, you put the answer there. 0.8 to the power 0, so 1. So you multiply all these, and you're going to find 3 answers that you're going to substitute now. So 6 combination 4 plus 6 combination 5 plus 6 combination 6. Collectively, the final answer will give you 0.01695. That is how you solve it out. Are we together?
I wasted time on this. I didn't understand what to do.
But now you get it right.
Mm.
It's a walkover. All right. Malulu, are we on the same page?
Yes, we are.
Please, if you are behind, feel free, I'll repeat it for you. Okay. So I'm really interested in those that are behind. The rest of them were ready with me during the afternoon, so they know already. So they're pretending not to know, but they know. They're just comforting you. So I can start all over again just for you. Now,
Okay.
the lifetime of certain electronic devices have a mean of 300 hours, a standard deviation 25 hours. Assuming these are approximated to the normal, what is the probability that you're going to have more than 350? So you draw my bell-shaped, right? And here, the mean always comes in the middle. The mean is what? 300. The 300. Now deviation, put it here, 25. Then what is the probability of getting more than what? 350. So 350, put it here. Then you shade to the right. So using ESA, illustrate, standardize, and shade. So the mean is always at the 0 here. And this 350 will standardize it. So what's the formula for standardizing? Z is equal to what?
Z is equal to X minus.
Are we together?
You weren't audible.
Yes.
No, I muted myself because I was expecting you people to start uh, explaining. Okay, so 350 minus 300 divided by 25, we get a 2. So these two, we read it from inside the table. So the table will give you the reading always from the start, from here to there. So these to 2, what is the reading? 0. What? 7, 9, 7, 7, 2, 2, 5. I think. So let's go to the reading for 2. 2.0 is 0.97725. Are we together? So because this reading is just from here up to there, to get the remainder, we subtract 1 minus that. So we're going to have 1 minus 0.7725. We're going to get 0.0228. That is the probability. Are we together?
Yes.
Mr. Collins,
Uh-huh.
can you repeat?
Okay.
I'm not clear on how I'm supposed to know that this one was supposed to deduct from the one.
So our mean is 300. And we're told to find greater than 350. So greater means we're shading to the right. And this is at 0. To standardize this 350, this 350 minus 300 over the standard deviation. What's our standard deviation? Our standard deviation is 25. So 350,
25.
we're going to get what? 50 over 25, which is what? A 2. So this is a 2 there. Now, the procedure is you need to apply. So this shading you're seeing here is a small shading. Whenever the shading is small, subtract from 1. So from here to here, the reading from the table, we're going to get 0. What? 9, 7, 7, 2, 5. So if this is 97%, obviously this small area will be 1 minus the probability that we read from the table, 0.9, 7, 7, 2, 5. All together, this will give us 0.028. That is the probability of the remainder here. Is that clear now?
Yes,
All right. The second part now asks us to calculate the probability that will be 300 hours or less. 300 hours or less, we'll draw our 300 here. Again, at 300 hours or less, it's just this part there. So if you want to know, this is just 50%. You can end there, or you standardize it. Z is equal to X minus what? Mu over standard deviation. So this 300 minus 300 over 25. We're going to get a 0. So when you check the 0 reading in the table, you find it at what? 0.5. So when you go to the table here, 0.00, we get what? 0.5. So you can choose, even if you want to subtract from 1 or you get it directly, it is still 50%. All together? So since this is 50%, so what's the probability? The probability that Z is less than what? 0.5. So this is what? 50. So 0.5. So we can multiply times 100. So this is in percentage, we can call it 50%, or just the probability is at 0.5. So that is what it means. What is the probability that they are what? The percentage that it would be 300 hours or less. So 300 hours or less, that's how you got this. 0.50 times 100 to 50%. So what is the percentage that it will be between 220 and 360? It's an interval. So 320 and 220 and 360. So we have 300 here. And here we have what? 220, and here we have what? 360. So it's an interval between these two. We know this is always at 0. How do we standardize 220 minus 300? It's 8. 80 divided by 25, what are we getting? 80 divided by 25, getting negative 3.2. Then 360 minus 300 is 60. 60 divided by 25, what do we get? 2.4. So you now read, what is the reading for 3.2 from the table? And what is the reading for 2.4 from the table? So you go into the table and read them respectively. So are we together so far?
Yeah.
Karen, are we together?
Yes, our together.
All right. So we're going to read now from 3.2, what is the reading, and 2.4, what is the reading? So negative 3.2. 2.4 is a positive, so we got 2.4. This is what? 99.18. And 9.18. And 9.18. Then the other one is 3.2 negative. What is the reading? 0.0069. So whenever you're finding an interval, just subtract the bigger number minus the smaller number. So this minus that is the probability we're looking at. Are we together? An interval will subtract the bigger number minus the smaller number. So we get 0.9911. So that is how 0.9911 was calculated. So that is where activity 2 ends. Unless there are any questions.